Okay, thank you very much, Manon. My name is Aris Witteborg. I work with an engineering company called HaskoningDHV. And my talk will be about how we are developing digital twins for our clients, in this case specifically for the water sector. I've been working in the Dutch water sector since the early 90s of the previous century, and always in the field of the primary processes of this water sector. I will explain somewhere in this presentation what the water sector is and looks like. So it's about the primary processes in the water sector and everything that has to do with information management, automation, digital transformation, etc.
Sorry, please, everyone entering, mute your microphone, please.
Yeah. So first I will explain a little bit in one sheet about our company, because it's the rather interesting aspect is that we are sort of reinventing ourselves as a company with our own digital transformation, and then I will explain what we think that a digital twin is and why the world needs digital twins from our perspective. And then I will present a concrete case that we did where we delivered a digital twin for a specific client. So that will be more or less the structure of my presentation. As far as I'm concerned, feel free to ask me questions during the presentation if you feel like that, or we can discuss the different things at the end of the presentation. So it's up to you. First, about our company. So we are called HaskoningDHV, and we are an engineering and consultancy firm, of which there are quite a number. So there is 6,000 of us worldwide, colleagues, I mean, over a lot of different countries. And our main thing, so to say, is we are about the built environment and the asset systems that we need in this built environment. So on the right hand side you see the different markets or themes or topics or whatever. So we're in industry, aviation, airports, maritime, harbors, the whole energy transformation, infrastructure like a rail or roads, etc. And we are very much about the designing them and engineering them, and then other parties like the contractors will actually build them. So we are on the designing and engineering part of that. It's been like that for more than 100 years. And since the 2016, we are sort of rebuilding ourselves, reinventing ourselves, that our board of directors put forward a new strategy, and in this strategy we should diversify, so to say, so that we are used to delivering reports, in short. So we do studies and we make designs, etc., and we put them in reports. And the new strategy is to bring our knowledge to our clients for a big part, not through reports, but through digital services. Like, so we put our knowledge within solutions that can be used by our clients to optimize their infrastructures or their asset systems or whatever. We've been doing that since 2016, and the whole digital twin concept is very much at the heart of the way we see our digital business. So we want to design and build and deliver digital twins to our clients, so to help them optimize their asset systems. So that's about our company. A little bit more on this digital twin concept. How do we see the digital twin concept? Well, on the left-hand side, you see the physical world. So in our case, that could be a wastewater treatment plant, or a harbor, or airport, or any type of infrastructure that the built environment needs. And on the right-hand side, so that's the future, the optimized, or the way to depict that as an optimized digital way, and in between is the digital twin, and the sort of the functionalities that we see for digital twins is from rather simple to rather complex. That's the first version is you take the data, measurement data from your physical asset system, and put that, for example, in dashboards, etc., that tell you something about the digital representation of this physical process. Could be a drinking water treatment plant or whatever. Next step would be that you use rather advanced technologies to predict the behavior of that particular asset system. So you take the data and you learn, and you can predict the future, what will happen in the near future within this this asset system. If you are able to do that, you can also use these technologies to prescribe, to do sort of decision support for the people who are running that actual infrastructure, as, for example, as a decision support system, or in an even more advanced way, do that machine to machine. So you can have your computers and your information systems decide on what kind of intervention you want to take within the asset system to, for example, optimize the performance. So this is sort of the heart of our vision on how we can apply these type of digital twins in helping our clients to improve the management of their asset systems. And this is the same picture, but then there is the different aspects from the information technology point of view. So on the upper left hand, there's your basic sources of data to start with, because the whole thing obviously leans very much on data, and a lot of data, and good quality data. And in the first step, you make your dashboard and you do your predictive simulation. And even with machine learning and AI, you can also do the prescribe kind of actions. And all the way to that you the machine-to-machine assessment of, for example, controllers or whatever in your physical system. So that's a digital twin-driven control of your asset system. So these are the different aspects that we see in the digital twins that our world needs, our type of clients need. And this is, as I said, at the heart of our digital aspiration or ambition as a company. As I said, that we want to be one of the companies that is leading in delivering these type of digital twins to our type of clients. And this, so as I said in the previous slide, there's sort of different maturity levels or complexity levels in these digital twin development. So it's not advisable to start at the top, the most complex type of digital twin, if you are not experienced in the lower maturity levels. So at the lowest level, that is the descriptive digital twin that tells you what is happening or what happened within your asset system in terms of performance or condition, etc. In the next states that is a little bit more complex as a digital twin is that it doesn't just describe what happened, but it also gives you the information that you understand why it happened within your asset system. So there is more to it than just representing measurement data in a graph on a screen, but there is additional analytics done to give your extra insight on why it happened. And the next step in complexity or maturity is the prediction. So if you know what happened and you understand what happened, or your algorithms understand what happened, the next version of the algorithms tell you what probably will happen within the near future, given all the data that are available. And the next step in complexity or maturity from that level is that your algorithms tell you how you can intervene on what's going to happen in order to run whatever your system is, a plant or whatever, at an optimal level. So it does decision support in that it tells you how to intervene in adjusting set points or whatever. And the highest level of complexity or maturity is that's machine to machine. So there is not an sort of an advice to an operator, but the platform, the algorithms know what to do, and they adjust the system machine to machine. So the algorithms change the set points in the process, for example. Well, and that's all. So there's different techniques at the heart of each step. So the lower level is pretty basic, of course. That's about which is mainly already done by process automation, distributed control systems, PLC, SCADA, etc. And every step that you go higher, you need more advanced, either data science, analytics, predictive simulation, etc. So, as I said, if you start thinking about digital twins, you have to be very clear on your objectives on the one hand side, but also on your starting point on the other side. So it's not, as I said, it is not advisable to start at the highest level if you have no experience in the lower levels. And this slide is more about the, it's not a matter of just technology. So you can always find the specialists and the programmers, etc., who are very able to put the solution that you think that you need for the problem that you think that you have, and write code and have some kind of software that does something. Our experience is that when you really want a digital twin for a certain, for improving any aspect of the business of your client, it's not just about IT and technology. There's a very important aspect which is the yellow column. That's about the impact that your digital twin will have on the business processes of the organization. So that can be very high impact, and if you don't analyze that on beforehand and deal with it during the process of developing and implementing the digital twin, you will end up with a digital twin that is not used. Because people, it's all about, in the end, it's all about people that accept the solution. So, and this is, well, this figure is that we have a certain framework with all the different aspects that are important in the journey from ID to an operational digital twin that you have to address one way or another during that the whole process or the whole journey. So it's well, the main message is it's just looking at it from an IT perspective is a very big pitfall in the the success that you will have in developing and implementing the digital twin. I can explain this if anybody is interested in the details of this framework. I can explain that separately, of course.
I am Aris. In your experience, because that's a general challenge in digital transformation, that people and processes are lagging behind. So a lot of innovation is in the end not adopted. Digital twins are even more complex, and some digital twin projects I know of start a higher maturity level than first at the basics. You have any recommendation on how you can involve people better, or from your best practices, what helps getting these transformation changes adopted?
Yeah, I think it's a very good and sound idea to start at the top of this figure, so to say. So you have to be very sure about the real business goals of the organization or whatever that thinks that they need a digital twin. And there should be a large group within this company that have this same vision on this ambition. What should the digital twin do for you? So you must, if you want to be successful, that's the very first step that you have to be aligned in. That the stakeholders should be aligned in the goal of the digital twin. And then, as I said, this framework, every part of this framework should be addressed. So it's not starting with the programming or the coding of the whole thing. And and how to involve, in the end, you have to put a lot of effort in involving the people that it affects directly. In our case, that could be an operator from a treatment plant. So the operator should accept, in the end, the digital twin. If not, it will not be used in the operation. And we put a lot of, I will explain in the case that I will present later. I will explain what we did to involve this and get the operators to accept the digital twin in their daily work.
Super, thank you. And if anyone else has a question, just let us know. Thank you.
So this well, this whole digital twin concept, we use it in different type of application areas. So I will give you now a real case in water management, but we also do it in crowd and traffic management and asset management, and that's the type of business processes and business goals that are important for our type of clients. So then I come to this particular case. This is about a client who runs 17 wastewater treatment plants, and that has chosen us through a rather complicated tendering procedure to be their partner for the coming 6 years, to develop, to help them become a data-driven organization through the implementation of digital twins. And we are now in the process of finishing the first of these digital twin functionalities, and I will explain that now. First, I think I have to give a very short lecture on the Dutch water sector. So what do we mean by the Dutch water sector? In the Netherlands, we have 21 so-called water authorities. and water authorities are responsible for surface water management in terms of water quantity, so not too little and not too much water at any given place in the Netherlands, and the wastewater treatment. So the wastewater that's coming from your household or from industry or whatever is treated in large wastewater treatment plants, and that are run by these water authorities. And drinking water is something separate. So we've got 10 drinking water companies in the Netherlands, and they produce drinking water and transport it and distribute it towards your households. This particular case is about what you see in the lower schematic is the sort of the wastewater system in the sort of generic view on the wastewater system. So the wastewater is leaving your home, and it's collected by your municipality in the sewer system, and the sewer system transports it to what's called a wastewater treatment plant, and that's run by the water authority. And this particular case is about a part of this this asset system. It's about the pumping of this wastewater towards through pressurized pipes towards the wastewater treatment system. In general, the reason for digital twins in the water sector in general is sort of threefold. What we see is that the Dutch water asset infrastructure is run by these organizations at a AAA service level. I bet that none of you feel the need to call either the water authority or the drinking water company because you're not satisfied with their service level. That's run perfectly in the Netherlands. But these asset infrastructures are getting more and more and more complex, because there is all kinds of new goals, sustainability goals. There is a climate change that affects our asset system. So there will be periods with too much water. There will be more periods with not enough water, drought. So the whole managing of these asset systems in the Netherlands is getting more and more complex. And these asset systems are now run that's very much leaning on staff that is highly experienced and have 20 or 30 years of experience, and who don't need very advanced information management landscapes or application landscapes or whatever. They just know how it works, and they run the system, and they make sure that it's run at a AAA service level. These very experienced people, staff, are rapidly graying, so to say. So a lot of the water authorities and drinking water companies know that they will lose this experience in a sort of an accelerating speed in the coming years. So in 5 to 10 years, there is water authorities and drinking water companies that know that they will, within 5 to 10 years, they will lose 50% of their experience years, so to say. So that's a serious threat to this AAA service level, and there's also this technology push. So these challenges are sort of the driver in the Dutch water sector for accelerating the digital transformation, in which the digital twins have a specific place. So this is the same story, but now in a schematic. So we've got more complex or a growing complexity in the asset systems themselves. There is more and more data coming from either the system, but also from the outside world. These data streams, so to say, are growing very fast. So there's actually big data. That's the perspective. And up here we have this graying workforce, and so there will be less experience years in the coming years and more information of more complex systems. So you don't want these people up here in the future to be busy with finding data, validating data, and managing data, and doing all sorts of stuff with spreadsheets and personal tools, etc. You want a situation where they get actionable insights. So this data should be processed into insights that they can take a decision on, and not be busy all day long with gathering data and checking data, etc. So to do that, to translate, so to say, these big data into actionable insights, in the water sector, there's three main sort of big chunks of technology that you can use to get these actionable insights from these growing data streams. And that is these three. So you have the promising data science, machine learning, artificial intelligence kind of technology, and there's this which is rather new, at least for the water sector. So there's a lot of experimentation is done in proof of concepts, etc., on how to apply data science. This is sort of a traditional, the simulation models is more about traditional technology. We've been using simulation models for decades now in the water sector, but it's always a model that is running on the laptop of a highly specialized hydrologist or whatever. And the next step in that is that you bring these simulation models online as a 24/7 environment for the staff to support them in their daily work. And there's also the promising 3D virtual reality, augmented reality technology that is growing very fast, and that will help these guys to keep a grip on their information and get the actionable insights. And that's what we call the components of the future digital twin to help them optimize their operations. And then there is one more component that's sort of the under the hood component. To do all this, you need a very well organized landscape, so to say. So you don't want to every individual application of machine learning or simulation to gather their own data and do their own data integration and data validation, etc. So there's at the heart, or not at the heart, but under the hood, you need something called the data lake, where all the data is brought together and integrated and validated, etc. This is what we call the digital twin as a holistic concept, and you should implement this step by step. Obviously, you can't do this all in a big bang and have a big bang. So over the coming years, these organizations will implement this step by step for the different technologies. Then about this specific case, so we have in this case it's about a water authority running 17 wastewater treatment plants, and these treatment plants get their wastewater from your households or the Limburg households by 149 pumping stations. And the case that the whole use case at the basis of the digital twin that this particular water authority wanted was sort of written down here. So they wanted these. They wanted an application that monitors the 149 wastewater treatment of wastewater pumping stations 24/7 in real time, and give in real time insights in the actual performance and health of this particular pumping station, and generate as early as possible the information about deviations from the normal or expected behavior of this all of these pumping stations. That's the real functionality here, is that sort of a predictive maintenance type of information that and that will enable these operators to prevent calamities and schedule maintenance in an optimized way, and overall optimize their whole operations, their whole business. And that was done in, well, the project was split in two parts. So the first is develop the first version of this lake that I told you about. So they know that in the future they want to use digital twins and machine learning and simulation, etc., in a very wide, broad range of applications. So they know that you need some kind of a data hub where all this information is gathered once, and a central source of truth for all the future the smartness that you want to apply. And so that's the first part. And the second part obviously is this intelligent system that monitors these pumping stations and brings the information to the central control room. It was all done, developed in Azure technology. So it was they didn't want a proprietary company delivering a specific solution, but they wanted to, because they know that this is only the first step in a long future of developing all kinds of new smartness in applications. So the main advantage of Azure in this case is that you've got all these building blocks that you can use out of the box, and that you sort of parameterize and with which you build the actual application. And it's all about scalability, because now it's 449 pumping stations, but they have the ambition to be service provider for pumping stations from the municipalities. So in the end, this solution must be scaled to, I think, maybe 3,000 or 4,000 pumping stations. So that's another reason to choose the Microsoft Azure Cloud as the basic platform, which is obviously future-proof as being one of the big tech solution providers. Yeah, this is in a nutshell what was done. So the solution monitors the behavior of the 149 pumping stations and analyzes in real time through machine learning the expected behavior of the pumping stations, and when there is deviations from the expected behavior, that's brought to the central control room and the operators immediately, and thus greatly making their daily work much more efficient. And I think this is my last sheet. So it was rather new for the water sector to develop this kind of solution in Microsoft Azure on scale, because there is a lot of proof of concepts done, which are regularly done in Microsoft Azure, but the proof of concept is something very different from an application that could run 24/7. Also when there is bad data, or also when there is no data. And in the end, the signal or the information that goes to the central control room should be reliable information for the operators. And so that requires something very different in infrastructure and platform, etc., than a proof of concept. And we encountered quite a number of and still do challenges, like because this is meant to be or implemented as a software or solution as a service implementation, and there's of course all kinds of questions about data ownership, and so now you don't have a lock-in with a small proprietary company delivering you an application, but there is fear of a lock-in with big tech, and so the lock-in with Microsoft, and there's questions about intellectual property, and the whole procurement of a software of a solution as a service is quite difficult for Dutch government, or difficult. It's new, so this is the type of or just a few of the challenges that we dealt with or are still dealing with. This is my presentation. So, any questions?
Mute myself. Thank you so much. Compliments in the chat. It's very interesting. Please, everyone, add your questions to the chat. I have two, because you were saying something about how to involve the operators, how to give them an extra incentive.
Yeah, well, what we did is so we knew based on our experience, and that the operator in the central control room was crucial in the acceptance of this digital twin. So what we did is that we did in the Agile Scrum way of working during the development of the application. After a few operators were already involved in the proof of concept, but when we started the development of the full system, then these operators of the control room were involved every 2 weeks. So there were sort of evaluation sessions for, I think, 3 months, every 2 weeks, with the operators to discuss with them the performance of the system, the user interface, the logic that was behind it. Can we understand why the system generates an alarm? And sometimes the system didn't generate the alarm that was generated by the system, in fact, was not an alarm, should not be an alarm. So that was all discussed with these operators. So they were, for 3 months, they were heavily involved in the whole functionality of the application, and that we are quite sure that was a big part of the success. Yeah.
Okay, thank you. I have questions from the chat. Did you consider Fireware as a open source solution? Chris is asking.
No, well, I know of the existence of Fireware, and as far as I know, within our organization, it has not yet gotten a lot of attention. We know it's there, but we have and also this the client made the choice for Microsoft Azure. So that is the sort of a given for us, and that's also why we won the project, because we know how to develop this kind of applications within Azure.
Yeah. As far as I know, but that's information a year old, not all the parts of Fire are already proven in practice and scalable. So that might also have been a consideration of the company. Chinwe asks, does the digital twin replace the existing maintenance solution like Maximo? If yes, how do you find the balance?
No, it definitely is not. so it's more of that if the digital twin decides that or it gives a warning that a specific pumping station is deviating from its optimal or expected behavior, then in the future, so now there goes an advice to, or the warning goes to the operator, and the operator has to decide whether or what action should be taken. So that could mean within 2 weeks, somebody should go to this pumping station and do something. And if so, then the operator would put this work order within Maximo. So he gets the information from the digital twin and he decides there should be a work order in Maximo. And in the future, that might be automated. So the digital twin might conclude that maintenance action is necessary and generate the work order within Maximo. So that would be machine to machine. The digital twin enters a work or generates a work order within Maximo. So it doesn't take
they're complementary.
Yeah, yeah.
Super. There's a lot of questions. Are there any connection with other water operators? It's also a question I had, because they might have different standard systems.
What do you mean of whether this solution would be interesting for other water authorities as well?
Yeah, or maybe I'm filling it in for Martin, using their data or using the same system.
Well, actually, within the whole tendering procedure, we are sort of contractually obliged to help this water authority to bring it to the attention of other water authorities. So that's a cooperation between us and this particular water authority, because this water authority understands that if other water authorities or drinking water companies would use this platform as well, there is of course a scaling effect for them in the whole maintenance and further development, etc. So that's the intention. Yeah.
And there's a question, this might be a bit difficult to answer. Could you apply the same process to operation of existing buildings?
Well, I'm no expert in building management, but
I think the levels of maturity and your model, yeah, I think that could be applied widely.
Yeah, that's at least that's our view, that if you you should be careful in choosing your maturity level. If you choose your maturity level or your complexity level too high, above your own expertise, so to say, well, you're bound for trouble.
Yeah.
And my guess is that you can use the same sort of framework or levels for other types of asset systems.
And you will share a report with us, a link for on it.
About this.
Yeah, in the beginning you said I can also share something on it, more about it.
Yeah, that's more on the framework for the business transformation. Yeah.
Yeah. Okay, super. There's a question about the information modeling before implementing the digital twin. Is it required? And also, if you can say something a bit more about the used interface facing standards.
Yeah, well, the data modeling, that there is a lot of data standards in the water sector, so that they are widely accepted and widely used, sort of standardized data models, which are at specific points maybe not detailed enough, but the basis was already there and already implemented by the water authority in other information systems. So that was a very good starting point, but you still have to actually, yeah, code it, so to say, or implement it within the Azure building blocks that you use. So that's still So it takes quite some expertise to understand these models, etc. But we didn't have to develop them from scratch. And for the user interface, I'm not quite sure whether or not that they used any type of standards or whatever. I'm not that involved in the development and the implementation of the twin. Can't answer that.
Okay, no problem. We can always ask.
Yeah.
There's more question, but I would just suggest that if you have some more time, that you also look in the chat. I will also, if you have some more time, ask. I do want to do one only if you can answer it, because there's a follow-up question on Maximo. There's a question on what time did it take to get this digital twin off the ground, and if you can answer, can you give an indication about building and maintenance costs of a digital twin?
Yeah. You want the answer now, or should I?
Yeah, I think that's and yeah, if you want.
Yeah, it took. So we won this tender in I think November or December last year, and we made the solution design in January, February, and I think the real development was started in March, April, and this month the whole system will go live for 149 pumping stations. So that's, I would say that the real development implementation time was about 6 months, I guess. And as I said, it's something very different from a proof of concept. You can do a proof of concept for 50K or something, and this is way more. I don't know the numbers, but that's serious money.
Yeah, it's also implementation.
Yeah.
Because it's really be used. So thank you very much. I really enjoyed it. And I think seeing from the questions, and I also have one question left, that you've enlightened us, a lot of new insights, a lot of questions. We do have a little thank you gift, which I will send to you, as I cannot give it to you personally. And if people want to follow up with more questions, they can reach you on LinkedIn. So if not today, if later you want to know more about the business case, you are on LinkedIn and very accessible, I have experienced. So thank you